Hello, good morning to everyone. Myself Dr. Mahadev Unde, Professor in Electrical Engineering, Zeel College of Engineering and Research, Pune. Welcome to my YouTube video channel, Electrical Machine 2. In a previous video lecture, we have learned the voltage regulation of alternator by EMF method, and the result obtained are little bit somewhat higher than the actual values, and therefore this method is also known as pessimistic method. In today's lecture, we are going to learn the MMF method, also known as ampere turn method or Rutherford method of finding the voltage regulation of alternator. Now here, in this method, the data uses the open circuit test and short circuit test that is obtained in EMF method. In this method, it is assumed that change in terminal voltage is entirely due to the armature reaction, and the armature resistance is mostly neglected, and the voltage drop due to the leakage reactance, that is IAXL, is neglected. Now from the open circuit test and short circuit test that has been conducted for the EMF method, we have plotted the OCC, open circuit characteristics, and short circuit characteristics here also. The x-axis is the field current and y-axis is the open circuit generated EMF. Another y-axis is the short circuit current per phase. Now OCC is plotted, and that is the curve as shown in the figure. And the short circuit characteristic is a straight line passing through the origin. Now for this method, what is IF1? IF1 OA, that is the field current OA, is IF1, and that is the field current required to generate a rated open circuit voltage per phase. Similarly, the IF2 is nothing but OC, and that is the field current required to circulate full load armature current per phase equal to short circuit current per phase. Then the next step is to find the resultant of IF1 and IF2, and that is nothing but say OB, and correspond to this field current OB, that is IF, find out the no load voltage generated per phase, that is E0. See, correspond to this OB, IF, we have to find out E0 per phase from the OCC. Then in case if the armature resistance is given to you, how to find out the phasor diagram? See, first thing is draw the OA as a reference phasor. OA is a reference phasor. Then draw the OI, that is the current phasor, by making an angle phi. Then add the AB. AB is nothing but IARA parallel to the current phasor, and add the BC. BC is nothing but IAXA, that is the voltage drop due to the armature reaction reactance, and that is drawn perpendicular to the current phasor. It is drawn perpendicular to the current phasor. Then join OC, that is E0. Our interest is to find if armature resistance is given, then how to find IF1. At what voltage we have to find out the IF1. So this VPH plus, consider the triangle ADB. Consider the triangle ADB, and from this triangle ADB, see, cos phi equal to AD divided by AB, and AB is nothing but IARA. Therefore, cos phi is AD upon IARA, and hence AD equal to IARA cos phi. And therefore, the voltage V'(pH) equal to VPH plus IARA cos phi. Now for this V'(pH), find out IF1 from the open circuit characteristics. Okay, how much field current is required to generate the open circuit voltage V'(pH) from the OCC? Okay, and further it is mentioned that in MMF method, voltage drop is considered entirely due to the armature reaction reactance, that is due to IAXA only, and by neglecting voltage drop due to the leakage reactance, that is IAXL, and due to armature resistance IARA. Now up to this, we have obtained the IF1, then IF2, then we have obtained the resultant of IF1 and IF2, that is IF, and correspond to this IF, we have to find out the no load current, no load generated EMF, E0 or EPH. But how to find the resultant of IF1 and IF2 for a lagging power factor? See, this is the phasor diagram and how to draw it. See, pay attention. IF1. What is IF1? IF1 is nothing but OA, and that is the field current required to generate rated open circuit voltage per phase. Then IF2 is nothing but AB, and that is the field current required to circulate rated full load current equal to short circuit current per phase. Now how to draw the IF2? See, once you draw the IF1 at point A, draw the vertical line, and from this vertical line draw the phasor IF2 lagging the vertical line by an angle phi, where phi is the power factor angle. Means we have to find out the voltage regulation at a certain power factor. Say for example, find the voltage regulation at a power factor 0.8 lagging. Therefore phi equal to cos phi equal to 0.8, and therefore phi equal to cos inverse 0.8, that is 36.87. So you have to draw the IF2 by making an angle 36.87 lagging the vertical line, and in this way IF2 is drawn, that is AB. Then join OB, that represent the IF, resultant field current, and this for this resultant field current is required to generate. What is the IF? IF is nothing but a resultant field current, and that is the field current required to generate no load voltage E0 per phase. Now how to find out this resultant field current? This is the triangle, and if the two sides of the triangles are known to you, you can find out easily the third side. That is the square root of IF1 square plus IF2 square minus 2 times IF1 into IF2 into cosine of angle between them. In this case, the angle is 90 plus phi, and in this way we can obtain the IF, resultant field current. Once you got the resultant field current, find E0. Find E0 corresponds to this field current. Find E0 correspond to this field current. E0 correspond to this field current, and then find out percentage voltage regulation, that is no load voltage minus full load voltage divided by full load voltage into 100. Now in case of lagging power factor, E0 is greater than VPH, and obviously this numerator will be greater than 0, and therefore voltage regulation is positive for a lagging power factor. Similarly, we can find out the voltage regulation at a leading power factor. Now see, leading power factor, in case of leading power factor, E0 is less than VPH. Okay, and see the nomenclature kept is same. IF1 is nothing but OA. Once you draw the IF1 horizontal line, OA, at point A draw a vertical line. Then how to draw the IF2? IF2 by leading the vertical line by an angle phi. Draw the AB. Then join OB. OB represent the resultant field current. Now once you got the resultant field current, see how to use the formula. Formula is, we know the two sides, IF1 and IF2. Therefore, IF equal to square root of IF1 square plus IF2 square minus 2 times IF1 IF2 into cosine of angle between them. In this case, the cosine of angle between them is 90 minus phi, and therefore once you obtain the resultant field current, find E0 correspond to this field current from OCC. And once you obtain the no load EMF per phase, we can obtain the percentage voltage regulation, that is E0 minus VPH upon VPH into 100. Now in case of leading power factor, as E0 is greater than VPH, the numerator is negative, and therefore voltage regulation is negative for a leading power factor. Similarly, for a unity power factor also we can obtain the voltage regulation. Now here the things are very simple. Now here draw the OA as a IF1, then draw the AB perpendicular to the IF1, that is IF2, then join OB, that represent the resultant field current. And it is very simple here to find out, because it is a simple Pythagoras theorem, and by using the Pythagoras theorem we can find out the resultant field current. And once you obtain the resultant field current, find out no load EMF per phase, that is E0 E0 correspond to this feed current from OCC, and then find out the percentage voltage regulation, that is E0 minus VPH upon VPH into 100. And now as the E0 is greater than VPH, E0 is greater than VPH, voltage regulation is positive. Or in general, as E0 is greater than VPH, voltage regulation is positive for a lagging power factor and unity power factor, whereas as or since E0 is less than VPH, the voltage regulation is negative for a leading power factor. Now let us summarize this method. Now after summarization, let us have a step 1, that is how to find the IF1. What is the IF1? IF1 is nothing but the feed current required to generate rated open circuit voltage per phase. Or if the armature resistance is given, then find out the feed current required to generate rated voltage V dash PH, and that is given by VPH plus IRA cos phi from OCC. Now step 2, to find IF2, that is the feed current required to circulate short circuit current equal to full load armature current. Then the step 3 is to find the resultant of the IF1 and IF2 by phasor diagram. Then once you obtain the IF, find out the E0 equal to VPH correspond to this feed current, resultant feed current from OCC, and then find out the voltage regulation given by percentage VR equal to E0 minus VPH upon VPH into 100. In this way, the same thing it is repeated here. We have finished the MMF method of finding the voltage regulation. Now after solving the numerical, it is found that the voltage regulation obtained by this method, that is MMF method, is a little bit higher than the actual values, and therefore sometimes this method is known as optimistic method. Okay students, we will stop here. Thank you very much.